Welcome to physics class. In today's video, we are going to understand about the calculation regarding the value of small g, that is acceleration due to gravity. Universal gravitational constant represented by capital G. Its value is 6.67 into 10 raised to power minus 11 Newton meter square kilogram inverse square. Mass of the earth represented by capital M. Its value is 6 into 10 to power 24 kg. Radius of the earth R 6.4 into 10 raised to power 6 meter. As we know, G equal to Gm upon R square. Let us fill the values. Universal gravitational constant 6.67 into 10 raised to power minus 11 into m, that is 6 multiplied 10 raised to power 24. R square 6.4 into 10 raised to power 6 square. G equal to 6.67 into 6 upon, we will write it 2 times cause it is square, 6.4 into 6.4 into, this is 10 to power minus 11 multiply 10 to power 24 into 6 to the 12, and it will become 10 to power minus 12. It can be written as 667 multiply 6 upon 64 into 64. 2 points means 10 to power 2, and here 2 points again 10 to power 2. They will cancel out into these powers. 10 to power 24 minus 12 minus 11. It will become minus 23. So while we multiply 667 with 6, it will be 4002. 64 multiply 64, 4096 multiply, it will be 10. When we divide this, answer will be 0.977 multiply 10. In turn, which can be written as 0.98 into 10, which is 9.8. This is acceleration due to gravity. That's why its units will be meter per second square. This is the value of small g. Is the value of acceleration due to gravity on the surface of Earth constant? Let us find the answer to this question. The Earth is not a perfect sphere, so its radius is not the same everywhere. The radius of the Earth along the equator is about 10.5 km longer than that in the polar direction. Therefore, the value of g on Earth is maximum at the poles and minimum at the equator. Acceleration due to gravity at height h is less than the acceleration due to gravity on the surface of the Earth. So, if we go above the surface of the Earth, the value of g decreases. In other words, the acceleration due to gravity decreases with increasing altitude above the surface of Earth. The value of acceleration due to gravity at a depth inside the Earth is less than that on the surface of the Earth. Value of g decreases as we go down below the surface of Earth. At the center of the Earth, the value of acceleration due to gravity, that is g, becomes 0. Motion of objects under the influence of gravitational force of the Earth. We know that an object experiences acceleration during free fall. This acceleration experienced by an object is independent of its mass. This means that all objects, hollow or solid, big or small, should fall at the same rate. According to a story, Galileo dropped different objects from the top of Leaning Tower of Pisa in Italy to prove the same. As g is constant near the Earth, all the equations for the uniformly accelerated motion of the object become valid with the acceleration a replaced by g. Equations of motion of a body moving with uniform acceleration in a straight line. First equation, v is equal to u plus at. Second equation, s equal to ut plus half at square. Third equation, v square minus u square equal to 2as, where u represents initial velocity, v represents final velocity, a represents acceleration, t represents time, and s represents the displacement. Equations of motion of the freely falling body are v equal to u plus, we will replace a with g, t. This is first equation. Second equation, we will replace s with h, it is height. H is equal to ut plus half gt square. This is second equation. Third equation, v square minus u square equal to 2gh. In applying these equations, we will take acceleration a to be positive when it is in the direction of the velocity, that is, in the direction of motion. The acceleration a will be taken as negative when it opposes the motion. Mass. The mass of an object is the measure of its inertia. We have also learned that greater the mass, the greater is the inertia. It remains the same whether the object is on the earth, the moon, or even in outer space. Thus, the mass of an object is constant and does not change from place to place. Or we can define the mass as the quantity of the matter contained in the body. SI units of mass is kilogram. What are the characteristics of mass? Mass is a scalar quantity. Mass of a body remains the same at all places. This means mass of a body on the earth, on the moon, or anywhere in the outer space remains the same. Mass of a body can be measured with the help of a two-pen balance. Weight. We know that Earth attracts every object with a certain force, and this force depends on the mass of the object and the acceleration due to gravity. The weight of an object is the force with which it is attracted toward the Earth. Force with which a body of mass m is attracted by the Earth is given by F equal to ma. Here we will replace a with g, acceleration due to gravity, so it will become F equal to m into g. This force is known as weight of the body. Weight of a body is denoted by W, so we will replace F with W. Weight, that is equal to mg. And weight has both magnitude and direction. Hence, it is a vector quantity and its SI units are Newton, cause it is a force. What are the characteristics of weight? Weight is a vector quantity. Weight is measured with a spring balance or on a weighing machine. The weight of a body is directly proportional to its mass. The weight of a body changes with the value of g. So when g decreases, the weight of a body also decreases. The value of g means acceleration due to gravity at the poles is higher than that at equator. That is why a body weighs more at the poles than at equator. Weights of all bodies, big or small, become zero at the center of Earth. Thank you for watching.